व्यवस्थित चाहता Looks what? Looks क्या? Meow. The sigma में जो वाला meow कौन करता है? क्या चूरी है बाकी? क्या देखी है उसे? क्या देखी? मैंने क्या देखी? उससे पहले भी खींची नहीं है। हाँ बच्चे को गलती हो गई। स्वाइप पे औरत ने तो देखा। औरत ने क्या? औरत? क्या? सर अभी आप 6 मिनट में प्राइवेट दे वाले कुछ समझ का और फोकस कर रही थी कहीं लड़की टम्बलर की क्या सिट रॉबर्ट टम्बलर तू तो बोल ही मत क्या मेरे क्लास में क्या मेरे क्लास में ये यूपी में नहीं स्कूल में मेरी मेरे क्लास में जो टीचर अच्छी है वो पहला डांटते फिर क्लास शुरू करते मेरे साथ भी वही होता है इससे कुछ हर दिन डांटता तो इतना प्राउड क्या हो रहा है उसके अरे क्या हंस के वो तेरे क्लास में नहीं क्लास वो तेरे क्लास के कितने लोग पसंद करते हो आप पता मेरी क्लास डेड क्लास सोनाक्षी को पहचानती हो हाँ सोनाक्षी काली वाली वो तो सोनाक्षी स्टोरी वाली सोनाक्षी के पास तो राजस्थान वाली एक येलो और वाली है जो काली वाली को भी है वेरी डिफरेंट पार्शियली वेरी सेग्रीगेट करते हो काली और मैं काला हूँ सरने ये काला सरने just पहले इसके बराबर टाइम क्या से मांग रहे जैसे हो गया तो देखना नहीं है उसके बाद क्या इसको शेक का भी जिसको क्या शेक टाइम शेक शेक क्या होता है मेरा शेक है अच्छा शेक तो बड़ा शेक है करके दिखा अरे क्या अरे अब ये लोग हर दिन देखता है अब मतलब क्या बोलते हैं हमारी क्लास 16 में थी हमारे पास स्मार्ट बोर्ड है हमारा तो हायर सॉरी आपने लिखा है इसीलिए ये बोला उसका पहले उसको पहले इसके पास ये तेरे पास टाइम डाल दे ये तो वाली बात ठीक है
Good evening, everyone. Sit down, sit down.
मजदूर वाली बात से किया क्या
बदतमीज ही है राइट हैंड डज नॉट वर्क
मैं बदतमीज I don't watch
Okay, where did we stop? Last class.
there was one direction थोड़ा पार्ट हो गया
चैप्टर में क्या कर रहे थे लोग?
तो आई ट्रैक वाला फर्स्ट फ्लोर हो गया सेकंड फ्लोर आई ट्रैक फर्स्ट फ्लोर सेकंड फ्लोर थर्ड फ्लोर माइट है थर्ड फ्लोर
क्या हो गया? बहुत ज्यादा प्रश्न क्या कर गया ये?
तो क्या कर रही है सर आपको थर्ड फ्लोर करा है बहुत सही था भाई
Excuse me, sir.
Swastika is a new admission. Then can I see you, Swastika?
दो महीने हो गए बस बस दो हम लोग भी दो ही महीने
Swastika, can I see you? You just left. Okay. So you have attended my lectures before?
Yes, sir.
How come I never noticed you? Okay, so I guess you have attended all the lectures, what I have taken so far?
Sir, I remember that you started with the laws of motion.
Yes. So I have not seen you before. So have you attended all the classes? All the chapters?
Skipped some in the middle, but I saw the YouTube lecture.
Okay, fine. So I think we have started with the third chapter and we have completed how many laws? 2 laws. Newton's second law of motion, is it complete?
No.
Did we derive the mathematical part?
Yes.
F equal to ma? Okay, fine. So did we do the graphs?
Yes.
Huh?
Acceleration. Sorry, mass forms.
Okay.
Acceleration.
Graphical representation एक ही हुआ है. Okay. So
एक ही हुआ है.
graphical representation of F is equal to ma. Okay. So there are basically 3 graphs. What are the 3 graphs? Variation of acceleration with force. So first graph is A versus F at constant F. So it is acceleration force graph at constant. See, there are 3 quantities: force, mass, and acceleration. Out of that, you have to take one constant and then see how the other 2 are varying. Okay, at constant F. So if m is constant, then what is the relation? There will be direct proportion. If n is constant, then force and acceleration will be
Direct.
proportional to each other, right? Which means, what should be the nature of graph? It should be a straight line.
Very strong.
It should be a,
The last relation between n and time.
this man,
N and time.
what is n and time? Why that? देखो, it's like this. M is equal to constant. Suppose you have the same body, right? On the same body, if you increase the force, its acceleration will increase. Okay, so you'll get a straight line graph. Okay. Now the second graph is. So now you can keep, like first case mass constant, you can keep acceleration constant. So F is directly proportional to M at constant A. Each time you can keep one quantity constant and draw the graph for other two. If you keep A constant, then F will be directly proportional to M. Right? So what is the graph? This also should be straight line. When will you get a straight line graph? Whenever there is a direct relation, direct proportionality, the graph will be straight line. Okay? So this also should be straight line. In this case, A is equal to constant. Now what you are doing? So if you increase the mass, you take different mass, right? If you increase the mass, then higher force will be required. If you increase the mass, greater force will be required to increase the, to keep the acceleration constant. This is what it means. Okay. So that is, so you got two straight graphs, one for force and.
Sir, to be written.
It's not really necessary, but I'm just giving you, and the inverse one I think we did in the last class. Okay. What was this? So whenever there is an inverse relation, you get a graph like this. This we did in the last class. Okay. All right. Did we discuss the units of force?
No.
Okay, let's discuss
Yes.
CGS and SI and gravitational unit of force.
Yes. FI is Newton and CGS is dyne. Is for 1 gram centimeter square.
That we've already discussed. And did we discuss examples of Newton's second law of motion?
Yes.
We have.
Yes, sir. Yeah, that consequences. Example is page 45.
Did we do it wrong here? Yes. A glass falling on the hard surface. Yes, we have actually covered it.
Yes, sir.
Only the graphs were to be discussed that I discussed today. Newton's third law. That is the next one. Okay, let us discuss now Newton's third law. Newton's third. Somebody has.
Yes, sir.
Why?
Sir, plus Newton.
Newton's third law. Bracket is used. बार-बार इधर जाता है. Now this is a very simplest law to remember, right? It states that every action
Has an equal and opposite.
has equal and
Opposite reaction.
opposite reaction. Every action has equal and opposite reaction. Now, what is action and reaction here? These are forces, right? where so the law is still here. Every action has equal and opposite reaction. There, action and क्या हुआ? Who is that? She's going twice.
पर दो सस्ती का
Action and reaction are forces acting on different bodies. Okay, so do they cancel each other?
Why?
If they are acting on different bodies, how can they cancel each other? If they are acting on the same body, then they might. Like in a tug of war, if people pull the same rope on different sides, so the force is applied on the same object. Not in this case. Like if two bodies are colliding, okay, two bodies are colliding. So they are not cancelling. Huh? Yes. So there is action reaction. Action is taking place on this body. Reaction is taking place on this body. So both are leaving its effect. Action is accelerating the body. Reaction is retarding the body. Okay. So where action and reaction are forces acting on different bodies, hence they do not cancel each other.
So this is to be written, right?
I think so. Hence they don't cancel each other. Instead, both forces leave the impact. Of the okay, clear it. We will have to understand it with the help of an example. So let us say you have two bodies which are colliding with each other. Attendance, just pass for the finish. This is moving with U1 and this was moving with U2. Such that U1 is greater than U2. Okay. So after some time it will collide. Let us say it collides here. So the first body will act on the second body. So this is force on the second body by a first body. This is the convention. F2 means force on the second body by first body. So this is action. And the reaction is on the first body and this will be F12. You see the forces are acting at the time of collision. So T is the time of collision. Okay. T is the collision time. During this collision time, the forces will be exchanged on each other. Okay. Now, what about these forces? They are not cause and effect. It's not that F21 is causing F12. They are not causing each other. In fact, they are acting simultaneously. They act simultaneously. Okay. So, after this, what will happen? The second body will accelerate. it will accelerate and it will get a new velocity v2. And this body will retard. But still it is moving with v1. Okay, so this will slow down, whereas this will go fast. We can note.
So, but in some cases it would come to this. It can.
Yes, depending upon if the masses are equal, okay. And it can also happen the other way. If it is too heavy, it will collide and go back. So it depends, right? If the masses are equal, then first body will stop and the second body will. Okay, if this was at rest and masses were equal, then this body may stop and this will go ahead.
So what if and
There are variety of situations possible. What if will be so many options? Okay, because there are different combination of masses, different combination of speed. So many situations are possible. Like there is only a ball and a bat, but every shot is different. Okay, because it is hit differently. So many angles wherever you hit. Okay, so it's like that. Is it clear? So what you need to understand is, in the third law, what is action, what is reaction? Okay, and they act simultaneously. Note action and reaction forces. Act simultaneously. They are not cause and effect. Is that clear? So, although Newton's third law is very simple statement, but it takes some time to get used to it. Yes? Nicholas. So, how do we express this law mathematically? F12 is equal to minus F. Okay, so they are equal in magnitude, but they are opposite in direction. Huh?
FAB is equal to minus.
Doesn't matter. You can call this body A, this body B. So symbol. I am using 1, 2. You can use maybe anything. Okay. So what is F12? F12. Where F1 is action. That is force on second body by first body. Okay. So action. That is force on second body by first body. And F12 that is reaction. That is force on first body by second body. When are these forces acting? During collision. During collision. During collision. So collision is the situation. Okay, it is the time, the brief time for which the two bodies will be in contact. Like when bat hits the ball, what is the time of contact? Huh?
few
Few seconds.
Few milliseconds.
Boss, 1 second में तो 3-4 थप्पड़ लग जाएंगे. 1 second is a big duration. It's a fraction of second. So but the damage done is so much. In collision, in a very short time, a lot of force is transferred. That's why whenever accidents happen, so the biggest example of collision is accidents. So bodies which collide, look at what happens to them. It completely gets disfigured. क्या होता है उसका? Destroyed completely. Right? In some cases, can't recognize also. Okay, so this is about Newton's third law. Now, any force can be called action, then the other force will be reaction. If I call this as action, then the other has to be called reaction. It's not fixed. Both are equal. Both are equal.
That's but both bodies will have the force to collide with each other.
Yes.
And that.
What do you
For example, the body A and B. both
That's
are-
why so the force are equivalent only, equal only. So any can be called as action. If you call one force as action, then the other will be called as reaction.
So if two
There's no
balls,
fixation.
if two balls, in pendulum, two balls of same weight have same height of string are dropped from the same height. After collision, what would be the reaction?
Like the balls coming like this, or one is stationary, one is
No, both are
If
coming.
one
at
is
the same-
stationary, ये hit ये रुक जाएगा फिर ये जाएगा
Yes.
ये ऐसे रुकेगा.
If both of them come together.
You got to see they will go back together. You should. And now the amplitude will reduce because after collision it will lose energy in heat and sound. यहाँ पे जो energy से आ रहा है, next time it won't go back so some energy is lost. And after some time it will stop. Okay.
So if the two pendulum, one is rocking and one is stationary. So it will lose its energy at a certain point.
Obviously, that also is going to stop, come to a halt. Otherwise, it will be like violation of energy. It will be magic, like if that activity keeps on happening. See, there is air friction. Every time it is, moving against air friction. So the energy is lost in overcoming the air friction. And then finally the amplitude reduces and it will become still. It has to end at some point. Okay. Now let us discuss some examples of Newton's third law. There are so many examples, but some are worth discussing. So consider a book placed on a table. Book placed on a table. In this situation, what is action? What is reaction? It is not a case of collision. It is not a case of collision. But in this case also, there is action and reaction happening.
So book is the action and the table is the reaction.
The gravity. So gravity is what?
The force.
So what are the two bodies here?
Sir, the table and the book.
The table surface and the
The gravitational force is applied on the book and the table, the force of
gravitational force is applied by Earth.
and
So-
the table is stopping that force
Where is gravitational force acting?
on the
On the book. Okay. So what is book doing to the table?
Pushing on the table.
Yes.
But the
So
table.
book is pushing the table because of gravitational force. That is because of its weight. So weight of the book is action. Weight of the book is action on the table surface.
But the gravitational force is not enough to go through.
Hello. Hang on. Gravitational force is not enough to break the table. What he get? Okay. So the weight of the book is applied on the table surface. That is action. Now the normal reaction of the table surface on the book is reaction.
Stopping it.
Yes.
So the gravitational force is applied on the book and the table is applying the normal force.
Yes. Gravitational force is applied on the book. Because of that, the book is applying force on table surface.
So the book is the action and the table is the reaction.
Yeah. The normal reaction is the table's reaction. Normal reaction is acting on the book, whereas the weight of the book is acting on the table surface. So the action and reaction are acting on different bodies. Okay? Is that clear?
So we can see as collision or it will be like.
This is not a case of collision. In collision, the time of interaction is very short. This is collision. But in general, what is the understanding? Forces always act in pairs. Never force acts alone. For example, if I hit the wall, at the very same time, I will also get hurt. Wall will hit me back, not after.
At the same.
At the same time when I am hitting. There will be no deal. Okay? These forces act simultaneously. All right. So there is not many examples given. There are many examples given in your book. So let's look at different examples of action and reaction. Look at this example. Spring balance. Okay. Let us say when two spring balances are fastened with each other. Let's say one of the spring balances, okay, there is a hook on the wall, right? So now you applied some force in this. So what will be the reading shown in the spring balance? Will it be same or different? Different.
Same.
Same or different?
Same.
Why?
The copy reading.
स्प्रिंग बैलेंस में दिखेगा ना यहाँ पे बीच में ये 0 है
सर
ये 5 10
अच्छा नहीं
and here 0 here it is 10 5 and 0. This is how it is, right?
Sir, because if we are pulling from one end, the force is directly being applied on the wall.
Both will show the same reading,
Yes.
right? So where is the force acting?
On the wall.
On the wall.
Between
It is acting at the point of interaction.
Yeah.
So when you are applying this force, right, because of this, the hook experiences force, right? Because of your force, right? So let us say this is spring A and this is spring B, right? So what is it doing? It is pulling this spring. Okay, so FBA. FBA. And here, this spring is pulling FBA. Both are pulling each other. And both are showing same reading. Okay, so this proves Newton's second law, Newton's third law. That action and reaction are equal, but they are both acting in opposite direction.
सर तो किस पॉइंट पे जाके वॉल पे प्रेशर पड़ेगा?
प्रेशर तो पड़ ही रहा है ना वॉल पे. अब देखो, is this spring moving?
Yes.
No, at equilibrium. Let us say तुम ऐसा खींचते थोड़ी ना यार, चल थोड़ी रहो, तुम खींच के एक जगह रुके हो. So जब तुम रुके हो तो तुम कुछ फिक्स फोर्स लगा रहा है इसके ऊपर, वो दिखा रहा है. तो बॉल भी तो उतना ही लगा रहा है इधर. बॉल अगर उतना नहीं लगाएगा तो ये स्प्रिंग खींचता रहेगा.
सर तो टोटल किलोग्राम का फोर्स वुड बी एडिंग बोथ.
No.
So
it's like this. When you're holding the spring like this, okay? It is the same scenario. Instead of pulling by 5 Newton, let us say, instead of pulling here, what was the pull? The pull was 5 Newton, let us say. All spring is showing 5 Newton, right? Now, if you weigh anything using spring balance, let us say you're weighing a weight of 5 Newton. The spring balance should show 5 Newton. Will it show 5 Newton or more?
5.
So what is the difference in the scenario? You're still holding the spring. क्या हुआ?
That was the spring there was
तो डबल कर दिया क्या? 10 न्यूटन कर दिया?
a constant.
वही समझ नहीं रहा है कि
नहीं तो नहीं होगा ना. देखो ये तो just it is pulling itself up by 5 Newton. Okay, it is the same thing like, let us say, where is the weight? It has weight, right? Now it is going down, down, down due to its weight, but now the tension is holding it. So will the tension get added in this? No, the tension is holding the weight. You get it? That's why now it is not moving further down. So tension is equal to the weight. So it is now balancing it. This confusion can make people mad. That's why I said third law is very simple to memorize, but to apply and understand. So it's not that confusing if you catch it right in few occasions. So you thought all the forces will get added. No, it's only one force, but in variety of situations.
so we have to count only one spring force.
Sir,
Obviously.
sir, so
This is the example. No? When I'm weighing any object, the weight is only 5 Newton. No? But if this was not there, the balance will completely move. So what this is doing is only balancing that 5 Newton. That's all. It's not applying any additional weight. It is balancing, and that's why the spring pointer is getting stopped at one point. Okay, this is very, people get confused here. So it's not like multiple forces. Force is only one, 5 Newton. That's the pull. That is reflected here. And the same thing is reflected here. That's how action reaction is verified. Okay. And this wall is there. So this wall is holding 5 Newton only.
Okay.
So everything is balancing. So everywhere there is a pair. Forces.
all of them have 5 Newton on.
Yes, exactly. Each point.
Each point
At
of
each-
contact.
Each point, everywhere it is 5 Newton. Yes, everywhere. Throughout it is 5 Newton. Okay, when the tension is same throughout the string,
Whole body.
whole body at every point. Is that clear? Let's go ahead. So with this we have completed Newton's third law of motion.
Okay.
Now you have so many examples. When you shoot a gun, तो क्या होता है? So you pull the trigger. When you pull the trigger, a spring is attached to the trigger. So trigger is pulled back. And then when you release the trigger, the thing goes and hits the bullet. Okay? And because of that,
पुल करेंगे तभी लगता
नहीं, pull करेंगे तो then you release. Pull means,
है अच्छा ओके
अरे load करेगा तो pull होता है ना वो. उसके when you pull the trigger, that's when it goes and hit. Okay? So when you pull, it gets stretched and then hits. When you're pulling has two things, stretching and hitting. Okay? So when it goes and hits the bullet, that's when what happens? Gun has applied force on bullet. So it comes out. Bullet also applies force on gun. That's why gun recoils. So whenever the gun shoots, the motion is like this. Gun goes back a little. That's called recoil. Okay? That's why when a machine gun fires, you see that there's vibration constantly. Bullet goes out, isn't it? Why did you laugh? So when the machine gun fires, whenever the bullet is leaving the gun, it also hits back the gun. And because of that, the gun goes back. That is called recoil. So why I'm using this example is there may be questions on required. So that's where you have to apply Newton's third law. Okay. Then how do you explain walking? Why? Using Newton's third law of motion, how can you explain walking? Yes.
Sir, for example, we are walking on earth. So when we walk on it, the footprint of our shoes applies on the gets printed on the mud. So
Explain me in terms of action and reaction. You have to identify what is the action and what is the reaction.
shoe is applying the force on the mud.
Who is applying or you are applying?
We are applying. This is, we are applying the force on the mud. And
On the earth.
the soil is applying the normal reaction on the shoes.
Yes. So basically you are able to walk due to the reaction of earth. When you advance your foot forward, you try to push the earth back. But instead, earth does not go back. It reacts on you and throws you ahead. Okay. So you are able to walk due to the reaction by earth. Is that clear? And you don't slip because there is friction also. While pushing, right, if earth throws you and you slip, then you'll fall right there. So friction avoids slipping and the reaction makes you advance forward. Okay. Likewise, motion of the rocket. What is action and what is reaction? What is action?
Action is the gravitational force applied on the.
How a rocket functions when the fuel is ignited. When the fuel is ignited, it begins to burn. Therefore, a lot of smoke is produced. So the pressure, so smoke expands, right? Then the exhaust comes out from a small nozzle. So it creates a lot of pressure downwards. And that creates thrust upward. Thrust is normal force upward. So the hot exhaust, the gases that comes out of rocket, it applies reaction in the opposite direction, that is upward. And because of that reaction, rocket goes up. So it is action reaction.
The rocket's thrust is the action and the Earth's gravitational force is the reaction.
No, the action is the burning. When the fume comes out, that is action. And due to the reaction, rocket goes up. Okay, both are happening simultaneously. So you can say action reaction. Action reaction are interchangeable. If you are calling the thrust action, then the reaction will be the exhaust coming. Yeah. Likewise, if you're stepping out of the boat, anchored, okay. So what happens? When you step out of the boat will be pushed into water. Boat will go away from the shore. Who is that? So not you guys. Okay, is that clear? Now we'll go to the E section, the last section of this, which is about universal law of gravitation. What happens? Okay, with this we move to the last part, which is the universal law of gravitation. So anybody has any question in Newton's third law? So all three laws understood. In school, which chapter going on? Ocean. Ocean in one time.
Laws of motion.
Started.
Yes, sir.
Which law? Which law is going on?
Motion in one direction, motion in one direction. Law of motion.
Which unit? Which topic? All laws covered? Not yet. So we are quite ahead, I think. In most of the schools, we are going ahead, right?
We are one chapter ahead.
then it's okay.
Yes.
So next topic is universal law of gravitation. Now, what is gravitation? Yes.
Gravitation is.
So, what is the cause of this force? Why this force is caused?
Gravitation force.
Is caused because of mass of the object. What is the basis of the force? Mass. Okay. So, we have observed gravity in case of Earth. Okay. But in general, any two objects which has mass, hear me out carefully, any two bodies anywhere in the universe, okay, there will exist force of attraction between them because of their masses. Understood? So this is universal law of gravitation. It is not only between an object and an earth. Any two bodies with mass separated by some distance will attract each other. This is called universal law of gravity. Understood? So therefore, there is a force of attraction between this table and me. Because table also has mass, I also have mass. Then why this table is not running towards me?
Because you don't have enough.
Mass. Very good. Because the masses involved are very small. Where do you see the effect of gravity? When the masses involved are very large, like in case of heavenly bodies. That's why Earth is able to revolve around Sun, because large force of gravity exists between Earth and Sun. Likewise, Moon is revolving around Earth due to large gravitational force between Moon and Earth. Okay? That's why object is also falling towards Earth due to large force of gravity between Earth and this object. The thing is, Earth is pulling it with some force. This object is also pulling Earth with the same force. You understand? Whatever force Earth is pulling this object with, the object is also pulling Earth with the same force. But Earth is not coming towards the object. Object is only going towards Earth. We'll see why. Okay?
Because the Earth's mass is more.
So, what is acceleration? Force by mass. If force is constant, acceleration is inversely proportional to mass. So, if the mass is less, acceleration will be high. So, its mass is less, its acceleration is high. If mass is more, acceleration will be less. No. I am just
Sir,
explaining in a different context.
sir, but the feather's mass is less, then how come it is not having the acceleration?
That is due to air resistance. We'll come to it. If it was in vacuum, then feather will also go down equally. The pen and the feather will go down at equal rates. Okay. Okay. Now, what is universal law of gravitation? Therefore, if you have two bodies of masses m1 and m2, let us say the distance of separation between them is d. D is the distance of separation between the center of two bodies. Then what this universal law says, it says that there exists a force of attraction. There exists a mutual force of attraction between two bodies, which is same in magnitude. Okay? Along the line joining the center of the two bodies. And this force is given as, it is directly proportional to the product of the masses and inversely proportional to the square of distance between them. This is the law. अभी पूरा हुआ नहीं और doubt आ गया. क्या doubt?
Agar, what if Earth's mass is more than Sun? Would Sun revolve around Earth?
Exactly. That's what is happening right now. Okay. You have too many what if questions. Huh? Okay. Now, the law says this, that the force between any two objects in the universe directly proportional to the product of their masses and inversely proportional to the square of distance between them. This is the law. Okay. So do you want to write the statement or it's okay? Liख लो statement. Write down the statement. Write down the statement of universal law of gravitation. Statement तुम book से भी देख के लिख सकते हो. Write the statement from book. What does it state? It states that between any two bodies of masses m1 and m2
Upon d square.
स्टेटमेंट तो बुक में से देख के लिख लो. ठीक है, या पेज छोड़ दो. तो अभी पढ़ लो, लेकिन लिखने से पहले पढ़ लो. Where is the statement? It is on page number
46.
Page 46. Every object in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. That's it. Okay. So when you write that statement mathematically, you'll get this expression. And then this. So what is G?
Gravity.
No.
Gravitational force.
Where G is constant of proportionality. Called. What is it called? Universal gravitational constant. G is constant of proportionality or universal gravitational constant. It is given as G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. What is the value of G? 6.67 into 10 raised to minus 11 Newton meter square per kg square. तो ये कैसे आया देखो, G को यहाँ पे रखो, F का यूनिट क्या है न्यूटन, D का क्या है मीटर स्क्वायर, M1 M2 क्या है kg into kg, है ना. तो G को यहाँ पे रखोगे तो यूनिट मिल जाएगा. Take G on left side, rearrange. Everything else you rearrange, you'll get the unit of G. So its value is found experimentally. We are not going into how the value is found, but this is the value. Henceforth, just like small g is equal to 9.8, capital G is this. Okay. Today we will find out why the value of small g is 9.8. Okay. Till date we have told you, use the value of G as 9.8. Today we will calculate. Is that clear? So now it will become clear to you if there is a force of gravity between these two also. By universal law of gravitation, any object which has mass will attract each other. Correct? So why these two objects are not attracting each other? Right? So we will see. So if M1 is equal to M2 is equal to 1 kg, let us find out what is the force due to gravity between two bodies whose masses are 1 kg. Okay, separated by and distance of separation B is equal to 1 meter. They are separated by 1 meter. Like this is 1 kg, this is 1 kg, and this is 1 meter. Then what is the force there? F is equal to G M1 M2 divided by D square. What this will become? Into 1 divided by 1 square, which is how much? Is this a big force or a small force? What is the magnitude of this force? 6.67 into 10 raised to minus 11 Newton.
Very small.
It is so small that it is almost zero. It is after decimal 11 zeros 667. 10 zeros 667. Yeah, because one decimal for 6 also. So it is almost like zero force. That's why you don't see any effect. Okay. Whereas if the mass is in case of Earth, what is the mass of Earth? Any idea? 6 into 10 raised to 24 kg. Almost. So if a factor of 10 raised to 24 comes here, and if the second mass becomes 1 kg, so now it becomes how much? 24 minus 11. कितना हो गया? 24 minus 11 कितना हो गया? 30. तो उतना बड़ा फोर्स लगेगा. Understood? Earth is exerting that force. So force का magnitude बड़ा हो गया. Is that clear? तो इसलिए छोटे objects में वो उतना visible नहीं है. This force. But as the mass increases, the force becomes appreciably large. Okay. So I hope you're getting the concept. Okay. Now we'll explore the relation between G and G. Yes, we'll explore the relation between G. Small g and capital. Okay. Both are same or different?
Different.
Perfect.
Small G, big.
What is small g?
Gravity.
Acceleration due to gravity. What is gravity? Force. What is gravity? Force. What is capital G? Universal gravitational constant. Now this is the thing. So get this thing very, very clear. Small g is acceleration due to gravity. What is gravity? Gravitational force. And what is capital G? Universal gravitational constant. Gravitational constant. 6.67. ये ठीक है, ये सब अलग अलग है. जब भी हम ग्रेविटी बोलते हैं, then it is gravitational force. समझ आया? जब भी ग्रेविटी बोलेंगे तो क्या है? Gravitational force. जब स्मॉल जी बोल रहे हैं मतलब क्या बोल रहे हैं? एक्सेलरेशन. उस फोर्स की वजह से कितना एक्सेलरेशन लगा? That is small. Now, so let us say this is our Earth, and this is mass of Earth.
So how much is the mass of the Earth?
Nearly 6 into 10 raised to 24 still.
Sir, why did you say CRT? Why did you say?
Because in your book, something else is given. In your book, the mass of Earth is given as 5 point something. 5.96, which is nearly 6 into 10 raised to 20. Okay, now to derive relation between small g and capital G, consider a small object of mass m falling freely near the surface of Earth. So it will fall by acceleration due to gravity.
Yes.
So consider an object of mass m is under free fall near Earth's surface. Okay, so by Newton's second law, therefore, by Newton's second law, what is the gravitational force? mg. Correct? कितना force लगेगा इसके ऊपर नीचे? And what is the force on the same object by universal law of gravitation? And by universal law of gravitation, what is F? It will be G M divided by R square. What is M? Mass of Earth. R is radius of Earth. Mass of Earth. And R is radius of Earth. So what is this R? R is the distance between the object which is falling near the surface of Earth. Now see, radius of Earth is very large as compared to this distance. That's why we have ignored this distance. We have taken this as radius of Earth. Is that clear? Understood? So that's why you'll get this force. So both are same forces. Isn't it?
Yes, sir.
So you have to equate them. So by equating 1 and 2, what do you get? So therefore, mg must be equal to gmm by r square. So m and m will get cancelled. So what do you get? Therefore,
G is
g
equal to GM upon R square.
yes. So now when you substitute all the values, so therefore g is equal to, you'll get 9.8. 6.67 into 10 raised to
Minus 11 multiplied by
5.96 into 10 raised to 24. Divided by what is radius of Earth?
4.
Radius of Earth is how much? 6.37 into 10 raised to 6. Into 10 raised to 6. Approximately it is 6,400 kilometers. Approximately the radius of Earth. So in meter it is 6.37 into 10 raised to 6. So when you solve all this, you will get ठीक है तो ये हमने ऐसे कैलकुलेट किया देख ले बेटा ये तो हाँ नहीं सॉरी वेरी इंपॉर्टेंट रिलेशन हाँ ये अर्थ और हाँ इसके बगैर ये डिस्क्रिप्शन का मीनिंग नहीं है सब कुछ लिख लो ठीक है if you have any doubts I will join in the next
लॉ है तो कैसा
क्या क्या क्या?
ये सेकंड लॉ यूज करके किया है क्या ये वाला?
हाँ ये सेकंड लॉ किया ना, यहाँ पे ए की बजाय जी आ जाएगा क्योंकि एनी ऑब्जेक्ट अंडर फ्री फॉल डेवलप द एक्सीलरेशन जी, पढ़ा है हमने पहले, तो इसलिए एक्सीलरेशन की जगह क्या आ गया, स्मॉल जी। ठीक है, तो विल सी न्यूमेरिकल्स इन द नेक्स्ट क्लास।
कॉल कर ले सेक्शन मध्ये कॉल कर